Hello friends, welcome to my YouTube channel Mustaq Kunnur Academy. In today's video, I will show you how to conduct a combinational biased clipper using Proteus software. First of all, look at circuit diagram. In this circuit diagram, we can see that the diode D1 is connected to V1 and diode D2 is connected to negative of V2, and one resistor is connected at the load and one resistor is connected at the input. Here we apply the sine wave and here we get the trapezoidal wave or the clipped output, as here we can see in this circuit diagram as well as in this waveform. Now we will perform this with the help of Proteus software. First, go to component mode and click on P. Type here diode. Here we can see that generic diode. Just double click on it. That is going to add in this list. We also need a resistor. Type resistor and select the resistor generic symbol, resistor symbol. Double click on it. And we also need a transformer. Type a transformer here and select simple transformer and double click on it. That is going to add in this list. And we also need the DC source. Type DC source here, select V source, double click on it. That is going to add in this list. We also need AC source. Type as AC source here. Should we carefully type the spelling? AC source. Here select the animated AC voltage source. Just double click on it. And we are done with the component selection. Now it's time to construct a circuit. First we will use the diode here. And rotate it accordingly. And rotate this diode. And we need a resistor. Take a resistor here. One resistor at the input and one resistor at the output. Change its value. Instead of 10K, I will make it as 1K. Click on 1K and here make it as 1K. Click on 1K and we'll connect here the voltage source. Click on V source. Here we'll connect the voltage source here. Since it is negative voltage, change its direction. Now I will make the connection here. The resistor should be connect here at the input and R2 should connect it at the output. Make the connection here. Now I will connect a transformer. Take the transformer. One terminal is connected to R1. Another terminal is connected to negative of this power supply. Take this alternator, connect at the input. Connect this here and here we have to change its voltage. Just double click on it. Here instead of 6 volt I will make it as 12 volt, and instead of 1 hertz I will make it as 50. Click on OK. Once we click on OK, now we have to connect a ground symbol here. Take a ground and here we have to connect to the ground one. Once we apply this input, now it's time to observe the output. In order to observe the output, we have to connect The oscilloscope, take the oscilloscope here. We can see here this is the oscilloscope. Now in this oscilloscope we have four channels. We use only one channel to observe the output. We are using channel A to observe the output here. Once we connect this, now what we will do, we will observe the output here. Just click on run. Once we click on run, here we see that we are observing the output. Now we will use two channels. We will use two channels. We will observe both input as well as output. Stop the simulation. I will delete this wire and I will connect one wire at the input and one wire at the output. One channel, and channel A is connecting to input, channel B is connecting to output. Now I will run this, and here we can see that in this digital oscilloscope, the channel A, that is of yellow color, channel B is of blue color. I will set the voltage channel A as 5 volt, channel B I will make it as 2 volt and change its frequency. Here we can see that the input is clipped in both the direction. In this way, we will get the output of combinational clipper. Here we can measure the voltage. I have set the channel B as 2 volt. Here we can see that it is having 2 division. Almost we are getting more than 9 volts. Now I will change this biased voltage. Let's change it. Stop the simulation and change its voltage. Instead of 1, I will make it as 4. Click OK, and one more voltage here. Instead of 1, I will make it as 4 voltage here. Click on 4. Now run this circuit. Now observe the waveform here. Go to digital oscilloscope, and here we can see that we are getting almost the 10 volt. How we get the almost 10 volts here? Because this is a 4 volt and diode takes zero point 0.7 volt, since it's silicon diode, 0.7 volt, and this turns out to be approximately 4.7 volt, and this turns out to be approximately 4.7 volt. Hence we will get the peak to peak approximately 9.6 volt. Hence in this way we conduct the combinational clipper. Friends, in order to get the continuous updates about job, scholarship, and these kind of technical video, please like and subscribe our channel. Thank you.